being represented as a piece of sand on the screen. And every piece of data is represented, so you actually see all of those things. And what is this data that I'm talking about right now? Well, right now we've got about 30,000 points from the last census, the 2010 census. And each of those points is a census-designated place, which is essentially a county. And we can pull up information and details about those. And you can see that these places have things like longitude and latitude and income and all sorts of things here. So you can see all of these things. And because I have longitude and latitude, one of the nice things is we can actually do a scatter plot of this. And you can actually see structure starting to emerge out of this. So you know, again, each of these, this is not a map of the United States. It looks like a map, but it's really just a scatter plot. And we're so familiar with the outlines of the United States that we start to see patterns emerge. And that's what data visualization is really about. It's about helping our senses interpret the data. If you just give us a bunch of numbers, or if you give students a bunch of numbers, they can squint and maybe they can start doing calculations or averages or just like, but they don't viscerally see what's going on. Again, about that visceral seeing, one of the things I can do very easily right here is do a histogram. And a lot of people go, what is a histogram? I don't know. If I just do this column plot now, you actually see what a histogram is. A histogram is counting up all the points in these bins and having it go down into those bins. Again, let me move that back and forth so you can see what's happening. I've actually shown this to 8-year-olds. They go, I get it, I understand what that means. And you start to even see patterns already in this data. So for instance, here in the Rocky Mountains and the desert areas, again, it's great for me to point, but you can't see my pointing right now, so you'll have to take my word that I'm pointing to this region. There's not that many counties because it's desert, it's Rocky Mountains, and you go, oh, okay, that makes sense. It's not very highly populated. We don't need a lot of counties. And I've actually look out here, you go, oh, there are not that many things to the East Coast either. I thought the East Coast is pretty densely populated. What's going on there? Well, if I switch to scatter plot, you actually see New England sticks out a fair amount. And that's why there aren't that many places, because there aren't that many places that far east. And again, a lot of people, when they draw the United States, they usually kind of go almost up and down on the East Coast, but you can really see this sticking out a lot. Now, just the position means some things, and we can find some patterns, but it's a lot more interesting when we actually start mapping colors onto this. So right now I'm going to map some colors. One of the nice things about this data is I've mashed up some of the election results from the 2010 election. So what I'm going to do right now is I'm going to color these things based upon Obama and Romney. And here what's showing was all the counties were above 50% went for Obama is blue, and below 50% is red for Romney. Now that's not exactly the way things were, third parties and other things, but it gives you a pretty good proxy for what's going on here. And again, you're seeing these things. If I switch back to that column view, you can see, oh wow, New England went almost entirely blue. There were only a few counties, and you even see the bands to the, the south, to the areas there. Here you see Southern California, Northern California, and in Washington State you can see how those went. And again, it's this sort of red county, blue county, red state, blue state, but it's a lot more nuanced than that. In fact, if we switch to a different representation of the colors, here we're using 10 different colors. Now you're seeing a lot more variation here. In fact, you can say here, if I click on the middle region there, those are all the swing counties. And you can see that there are a lot of swing counties. And you can see, wow, okay, this is more complicated than the very simple red state, blue state thing. In fact, we can also divide this up. If I say, let me facet this, let me show you small multiples. And now we have 9 different maps of the United States. In this upper corner map, I'm just trying to help you see that little clip there. And that upper corner map, that's the people that voted really strongly for Romney. And down here, those are the counties that went really strongly for Obama. And so let's take one of these counties here. One of the nice things is we can select any of these things. So if I just select one of these counties up here, actually I selected a whole bunch. So any guesses of what might have been really strong toward the west for Romney? Anybody? What?
Alaska?
Yeah, this is in the continental United States, and it's sort of to the west. Again, these are 9 maps of the United States.
Orange County.
Close. Actually, it's easier than that. It's Utah. Because, yes, that's where Romney was from. And you can say, okay, yeah, it makes sense that Romney took some county in Utah from 90%. But if we actually select, and I can just click on Utah there, you can actually see there were places in Utah that did not go overwhelmingly for Romney. There were places right in that middle area that actually were swing counties. Turns out that they still went 48% for Obama, 51% for Romney, so they still ended up going with Romney, but you could still see these variations just by exploring the data that way. So let me actually take off the faceting, and you can see again Utah coalescing into that, so you see all those counties in Utah. So here's another thing, which is a little less political, but not much political, but let's connect income onto the colors. So here, red represents low income, and blue represents high income. And I don't know about you, but I don't see a lot of blue on this map. You've got blue sort of in the New York area. Maybe, again, I don't know how well that's calibrated up there, but there's a little bit in LA, San Francisco, Seattle areas, all those things. But again, you're not seeing a whole lot of blue. Let's actually kind of put this into this mode so we don't have as much overlap. You can see some of the variations in here. Again, a lot of red in this map. One of the things I like to do is, okay, we preserve the geographic orders when I shifted to this view. So we took, again, Southern California and Washington on that left bar. But we can actually sort the colors here. So let me actually sort the colors. And therefore, we'll count up how many places in each of these buckets have blue. Just a little sliver at the top. And again, that's interesting, but let's actually just map income and just do a histogram of income. And again, I'm doing this all with touch. Here, 26K is about the poverty level, and all those counties are living with a median income level below the poverty level. That's, again, pretty striking. Again, these are counties. Some of these counties have only 500 people or so, and some of the counties have much more. It's not people, but it is showing how many counties are living at that income level. And one of the nice things about showing statistics and allowing you to interact with it is to be able to show correlations of this data. So I'll switch back into the scatter plot view and do income versus unemployment. And again, it makes sense if you start looking at it. If we go out to the right axis, if we go all the way over to the right, we can see high income means pretty low in unemployment, which makes sense. What I like to do, though, is change income to something that's probably near and dear to a lot of people's hearts here, is change income to education. You see the same curve, which is to say, the more education you have, the lower the unemployment. But again, that's nice to see. We can select some of these things up here. Any guesses where might be the lowest educated and highest unemployment in the country might be?
Is it Utah again?
Nope. Closer. It's Apache County, Coconino County, Navajo County. They're all Indian reservations. Every single one of them has really high unemployment, really low education. But let's look at the other side. I kind of like to point this out because, again, I'm not sure how well it's showing up on this big screen. Yeah, it shows up pretty well. The further to the right that we go, the higher education it is. In general, the lower unemployment. Also, in general, the bluer it is. We're showing three variables at once. Bluer means higher income. So that is a general trend, but you're seeing some weird outliers here. And you're going, what's going on here? This place here had 95% of the people in that county have a bachelor's degree. That's how we're defining education in the census. 95, but they're really not making much money. They're pretty red. So where do you think is a place that has a lot of educated people? 95% have bachelor's degrees, but they're not making much money.
Microsoft.
I think they're making a fair amount of money, unfortunately, but what's that? I think I heard someone say it. Universities. It turns out this place here is Stanford, where the median age is 23. And you go, oh, okay, that's interesting. And if I go to some of these other places, here's where it's been. That place there, if I just get this place here is Forest Home. That's where Cornell is. In fact, if we switch this to a different view, if we actually just we put income here, if we select every single one of these things down here, each one of these is a university town. We can just go through, that's Tompkins House. Select all those. Again, so that's Chapel Hill, North Carolina. I keep on kidding these things. But again, every single one of those places is a university town. And again, it's kind of interesting to see, yes, and this curve is actually kind of inspiring, which is to say, in general, the more education you have, the more income there will be in a county, except when you're a college town, which means that eventually you'll probably move away to one of the more affluent counties. So let's show you a couple other stories here. Let's switch back to longitude versus latitude here. Does anybody know, longitude here. Does anybody know how these zip codes are laid out in the United States?
Zeros.
Yeah, so let's actually look for the zip codes here. Zip codes. So if I hit a 9, we're going to hit all the zip codes that start with 9. And if I hit an 8, we get all the zip codes that start with 8. Actually, I'm going to move this down here. And if we hit a 7, we have all the zip codes that start with 7. Except you can see that there's something weird going on. If I hit a 5, we get all these. And it's like, the pattern here is not making sense to me. Why is there this little bunch of stuff up there that start with 5? Anybody from Vermont?
05.
Exactly. It's 05. And it turns out that when I was cleaning this data, at one point in time I was dealing with these numbers, these zip codes, as numbers. And when you're dealing with something as a number, if it has a leading 0, you can ignore that leading 0. So we just stripped it off. We forgot about it in the data. And I didn't notice that until I put it into this tool and I hit these numbers. I go, oh, it's gone. I made a mistake. And I actually purposely left that mistake in. I think it makes a great illustration, which is that you can be doing all sorts of manipulations of the data, and you have to be careful. You can make mistakes and not even realize it, and not notice it until much further down in the line. And visualization can help you understand the patterns of that data. Let me actually go off to 9 and then 8. And here is just Western Washington. And one of the things we can do here is just isolate that, just look at Western Washington. And now we're looking at this hot spot of high income in the middle of Western Washington. Any guesses where that might be?
Redmond.
Turns out that it's Medina, Mercer Island, East Bay, Medina. That's where Bill Gates lives. And it makes perfect sense that he's living in this hot spot of high income. And if we actually switch this to median home value, you can see, yes, there's that peak of median home value. Yeah, okay, that makes sense. Actually, I was kind of surprised that it was only $1 million. I was like, really? Bill Gates is probably living in a more affluent area than that. But if we let in all the rest of the income, it turns out the census caps out at $1 million. So those are just the peaks that are just there. So let me just take one more moment. I'll load in another data set here and show you that this isn't good for just maps and demographic information. Here we have data from the Titanic. Here, every single point is representing a passenger on the Titanic. And what we can do is, there's no more geographic meaning of this, but we can look at age, we can look at gender, and we want to see, did they follow the age-old adage, women and children first? Well, how can we see that? Let's color this based upon whether someone survived or not. And actually, we change the colors to a slightly different color thing. So here, red means they didn't survive, green means they survived. It's pretty clear from this that they followed. Let me sort by color here, and you can see, wow, yes, more women, certainly by percent, and certainly absolutely survived. But that's not really the whole story. If we actually facet this and look at this by cabin class, you can see that nearly all women in first class survived, and nearly all women in second class survived. But in third class, only about 50% of the women survived. So again, you can look deeper into the data and start seeing these patterns emerge. So with that, I'm going to pass this over to David.
Thanks, Steve. My name is David Brown. I'm like Steve, fascinated by the potential of computer graphics to solve problems in the real world. One of those problems is trying to make sense of data, which is growing in complexity and size all of the time. Of course, one approach is to build ever more complex tools. The other is to try and leverage our incredible abilities to visually process information, much like we've been seeing here, as people, to try and make sense of the data, to find patterns, to find clusters, etc. So what I'm going to demo here is an early version of a prototype called NuiGraph, that's natural user interaction and graphing, to spell that out, which tries to demonstrate how you can use our visual processing ability to find patterns. I preloaded a data set from Microsoft Excel. It was actually exported as a CSV. This is an Excel file. It's got about 42,000 rows of data in it. And Those rows represent tornado events that have taken place in the United States over about the last 40 years or so. So each row corresponds to a unique tornado. Now, I actually moved to the US from the United Kingdom a couple of years ago, and coming from the United Kingdom, I didn't really know much about tornadoes. So this was an interesting exploration of how I can learn about a subject, about tornadoes, by visually exploring a data set that I just downloaded from the internet. So I've preloaded the data set, but you can't see anything on the screen because I haven't specified how the data is mapped yet. So what I'll start by doing, so I'll go to my little spatial control here, and these are just the column headings of the Excel file. And I'll put, say, longitude along this axis and latitude along this axis. And like Stephen's demo, you're starting to see a shape come about. I mean, it's pretty much like an outline of the US. And all that's really telling me is that of those 42,000 tornadoes pretty much happen everywhere in the US, although there is an interesting distribution which we'll drill into in a second. Like Stephen, I'm representing each one of those rows in the data as a unique point, a little cube in this case. This is also an interesting experiment in 3D. And so each one of those rows is always on the screen and represented by one of those cubes. So let's start trying to clean this up a little bit to make a little bit more sense of what we're seeing here. I can also adjust the size of each one of these cubes. And I'll do that by applying one of the other columns in the spreadsheet, which was the strength of the tornado. Tornado strength, it seems, go from 0, which is the mildest form, to category 5, which is the strongest form. So I'll just apply the strength field to the size of these cubes, and I'll apply it to each axis of those cubes, so they're uniformly scaled. You can now start seeing there's a little bit more structure starting to appear. There's some clustering going on around Colorado, I think, some around the coastlines in Florida, and a few little pockets around the mountains in California as well, and then probably the Olympics as well in Washington. Let's apply some color as well. So again, I'll apply color to the strength field, and I'll have blue as the weakest type of tornado, and white. So white are the large